Hello everyone, welcome to yet another livestream. Hi the Mr. X, hi the Happy, hi the Mr. Best, hi the dog that can explode. Hi! Hopefully everyone's doing well and not feeling cold. And the Mr. Best, the cold emoji. Feeling good today. I'm glad you are. I'm really glad you are. Just want to say that I love the Higgs foreshadowing bit. Yeah, I will have to make a video about the Higgs and difference in energies, won't I? That'll be a pretty solid relativity video. With what happens at different energies, at different velocities, different accelerations. Oh boy, oh gosh, or golly. It has been a video. It's finally the next day, so I can finally ask you all, how did you all like it? The video. The different kind one, with more jokes and whatnot. The video made me more relaxed and look cool. I appreciate that. Looking cool is a goal. If science doesn't look cool, is it even science? Today I thought that we could just take things slowly. You know, I ate before the stream, I have coffee, I have water, I am rested, I am chilling, which means we don't need to rush. This can be just a slow, long stream, you know? There's some God particle level jokes. There were a couple good ones, really, weren't there? Great video, and the intro was great, like the rotating camera animation was great. Thank you. Yeah. I mostly like the jokes in that video. It is my favorite video I've ever made, simply because it's funny. It is the funniest video I've ever made, and I can't help but feel like there's some correlation between the videos I like and videos I consider just funny. Where's the top 16? That's where this has new thumbnail, because yeah, this is my new favorite. Like, yeah, there's certainly some correlation. Also, these are just the most recent videos. The other videos were, but 500 days now, 607 days. Huh? Hi, the Boston Cheetah. I don't quite get what you mean. Didn't you say that momentum and something else has to be preserved, but mass doesn't? Yes, mass does not have to be preserved, simply because mass is a consequence of energy. But due to relativity reasons, long story, it's a really long story, due to relativity reasons, mass and energy don't correlate 100%. Also, yeah, I'm gonna script the next video right now, so. Do you like math or computer science better? I failed to see the difference between them most of the time, so I don't know. Then why Higgs boson? That's because when it comes to, here's the thing. Actually, phenomenal question, Mr. X. I don't think I explained it well enough, did I? Basically, when it comes to, when you have high energy, alright, then you have a lot of energy, and this correlates to a lot of mass. This is going to be an oversimplification, by the way, but basically, if you have a lot of energy, then this also creates a lot of mass. You know, the famous thing, E equals mc squared. Some guy said it, I don't remember who, Feynman, Schrödinger, maybe it was Newton, someone said it, E equals mc squared. Now, the problem there is that we have certain particles, like for example quarks, which even at extremely low energy, still have some kind of mass. Now, this doesn't make sense, because if E equals mc squared, then how can you have a lot of mass and not a lot of energy? C squared is a constant, of course. How can you have this be high and this be low? And so basically from there you get a Higgs field, which is like a way for you to just get potential energy. So this would be additional energy, potential energy, if in the form of the Higgs field. So there we go. The other thing I can remember among other things is that tau particle is pretty big. It is the biggest lepton. Yes, it is. Well, it's the most massive one. I don't know if you can actually... I know how we can quantify size in the quantum world, how well. But yeah, this is basically, it makes sense. Yeah, I didn't explain it all that well because I was really rushing at the end. I really wanted to finish the video that day, and it was 3 AM. But that was yesterday. Why am I talking about that day? That was yesterday. Boy, it feels already like it was a week ago. something is clearly off with me. And so, right, that's why Higgs field was such a big deal. This is an oversimplification, but that's the basic idea of it. That is something I should make a video on at some point, about how, you know, at high energies, mass makes more sense than at low energies. We need the Higgs. How electroweak force, we have electroweak interaction at high energies, but then as the energy lowers, it breaks away into the electromagnetic and the weak interaction. That's something that also happens with lower energy. When it comes to high velocities, when v is really high, then the 4 dimensions become equivalent. It's really weird. Hi, the funky. It's not philosophical, which is what got me most hooked, ironically. Actually, it's physical. It's not philosophical, it's physical. You can skip the middle iloso part, you know? Is charge coming in thirds a real thing, or just convenience using a value of 3 times the current one? That's the pickle there. When it goes to quarks, it's hard to say if quarks exist. The more research because here's the thing. From a physics point of view, they exist. Yes, they are a real thing. However, in quantum world, real doesn't mean exactly what it means in the classical world. So when we see a ball in the classical world, we see a ball, right? That's what we see. We see a ball, a thing in the free space, a ball, an object. In the quantum world, however, when you have things like photons, like, are photons real? Well, I mean, electromagnetic interaction is certainly real, and the way it interacts with charge is certainly real. But what about photons? Are they a real thing, or are they just our interpretation? When it comes to particle physics, physicists don't care. They just don't care if they are real in that sense. But it is different. I really like the thumbnail for Horseman Physics. I also do, but it's not clickbaity, apparently. Of course I remember you, Bedinak. You gotta stop asking me at some point. Anyhow. We can relax today, you know? I finished the video yesterday, and I have 5 more days to finish another one. How is everyone doing, by the way? Also, how is everyone doing on this fine day? Just sip some coffee to wake myself up. Put some chill music on. Oh, I do have some chill music, actually. The only problem is my taskbar is broken. Shocker. Can quarks be just energy interacting with Higgs field? They wouldn't just be well, quarks interact with everything. Absolutely everything. That's the beauty of them. They couple with Higgs field, if I'm not mistaken. Well, they have mass, they have to. Strong interaction, charge, weak interaction, gravity, I think, too. Well, they have mass. So... Any ideas of the future? Future of what? In general? Well, I feel like conquering a galaxy would be nice, or at least transcending my mortal frame in order to become a transcendental being. I feel like that's a decent idea. I'd love to school in a few moments. It's fine, Funky. Rest time already over. It's not even past 1 day since you finished working that video. Yeah, it's weekly uploads, Gemma. It's about time that I work on the next one. I finished one, and I have well, I finished 2 days late, so I have 5 days actually to finish the next video. Rest time is over. By the end of this live stream, I really want to have all of these segments scripted, and at least the basic animation set up. Cancerbad, make it put a lot of time into that. I didn't even come up with a name, Cancerbad. That was Atomic. I just stole that from Atomic. Cancerbad is a perfect name. Absolutely perfect. Gets the point across. Yes, this is my chill music. That's my chill music. That's all I have chill music wise. There we go. How does make it make weekly uploads? Insanity, madness, a bit of schizophrenia, but that's only a bit. Do I see chemistry? Yeah, I mentioned it's gonna be a chemistry one. It's not going to be... I mean, I do call it an organic chemistry video, but that's only because it's the most organic chemistry. It's just gonna be red book. Right? This is the red book. Wait, was it red book or blue book? Oh, what was the 4 letters? My goodness, my brain isn't braining. Ayupak. That's 5 letters. Red book, if I'm not mistaken. Oh, was it red book or blue book? I think it might have been blue. Okay. Have you been keeping an eye on the organic questions in the chemistry channel? I have, but that's not what the videos will be about. That is what mainly motivated me to make an organic, but this is going to be my introduction to organic. So just how like I made simple videos about quantum mechanics before going into particle physics, this is that exactly for organic chemistry. So this is the basis, so that then in the future when I actually expand on it, I can just link back to this video instead of reinventing the wheel each time. I actually think I've come up with a pretty good way to go for it. So basically there are 3 concepts which I feel like once explained correctly, organic chemistry actually clicks pretty easily. So basically atoms want to have the lowest amount of energy possible, like duh. Second of all, atoms are actual physical objects, as in we can treat them in a more classical way than quantum and it will be fine. So we can think of electron clouds as having different shapes. And then atoms are too complicated for us to actually solve mathematically, hence why most of these will not have a underlying particle physics reason behind them. And then I feel like if I explain these 3 concepts correctly, then I do believe that chains and basics of naming will be just a breeze. Chemistry in the insular medium is apparently really effed up. Yeah, actually Flame is doing research on that. Flame is building a whole machine to do research on that. Conquering a galaxy on a $2 per month budget. Yeah, you need to exploit intents. That's what you need to do. It works. I'm just saying. I remember the web design was awful. But I also remember that I always found my way to the actual book in the end. It was awful, but at the same time it worked. This is the red one. Inorganic, which is not what I care for. I care for the blue one. No. Would you happen to have a link? Wikipedia, or can I just go this way? There we are! PDF! Oh, my beloved. No, that's not the PDF. Wait, is it? Oh my goodness, that's even better actually. Wow, never mind. What an absolute killer of a PDF. Scratch that. This is much better than what I was looking for. I was looking for the full book. This is... Okay, this is incredible. Wow. The entire naming convention summarized into 4 pages. This is beautiful. Talk about specific organic molecules. I will talk about specific organic molecules, but only when it comes to their names, as in what their names mean. I will not talk about the different consequences of different things, because that's above my pay grade. I don't know organic chemistry that well. This statement doesn't make much sense because of things like the existence of gravastar and the laws of gravity. Which statement? You need to be a bit more specific. I say a lot of things. I'm studying isn't stable enough to exist on Earth. That's such a wild statement to say about something actually studying on Earth. Atoms have something in common. We have no energy. Atoms have energy. Atoms have crazy lot of energy. They're made by the strong interaction, for goodness sake. That's a lot of energy. Make it, are you ignoring me? No, I've just been talking to myself before reading the comments. So many 5 atom rings. This is a killer of a document, I gotta say. A brief guide. This is so unbelievably cool. Hold on. I'm already linking it, even though I would still like to get the full book. There we go. Who made this? I need to... Yeah, I need to take these credits and I need to paste them in massive letters for that segment, because this is just... Mwah. I mean... To summarize the whole convention into 4 pages. Oh, another thing we'll need to do is we'll need to set up geometry nodes for creation of the chains, which will be fun. Are you eventually going to explain semiconductivity? I have animated and edited the video on semiconductivity to the point of semiconductivity. The only problem is that video was supposed to be about electricity in general, so I just can't bring myself to finish it. I might upload it as a just shorter upload in like 3 weeks, maybe 4. I got the stream of the guy who made this book. I don't think they have a stream. If IUPAC had a stream, my goodness, I would go for it. That's the book I meant. There we go. It's a fair bit bigger. It's just a fair bit, so obviously we're not gonna go over the whole thing. Because, well, I mean... I don't know, it would be physically possible for me to go through the whole thing. In 5 days. I know a fair bit of it, but it's nice to have a source I can just point to. It will be mostly, the whole video will be mostly just centered around this book. All the information will be just from my previous videos. Chains will also be a fairly short chapter. It will be just basics of naming, except slowly transitioning into. And yeah. I need to get myself into the crunch spirit, you know? I need to... It's really difficult. It's always the easiest for me to force myself to overwork when I'm about to finish a video, because, you know, then I can actually motivate myself. Like, oh my goodness, make it. If you just walk for like 7 more hours, you can finish the video. Hexagons are the bestigons. I don't know, actually, if in this case hexagons are the bestigons. I don't think there is a reason for hexagons. Cyclopentane is a thing. You don't need hexagons. I don't know. So, I mean, to be fair, I have seen cyclohexane more than cyclopentane, but that could be just me not, you know, not being an organic chemist. Should I hop in VC? Oh, please do. Always. Why did chemists make a whole subject out of chemistry but with carbons? Because carbons are so useful. Actually, give me all a second. Oh.
Hello.
Hi, Flame. Hold on. I need a second. So, you have a second to, like, introduce this. I don't know. I feel like everyone knows it at this point. Give me a second. I'll be right back.
Hello, people. I'm a master's chemistry student. And I'm here to help you all suffer with organic chemistry.
Okay, and I'm back.
Welcome back.
Hi. Yeah, it's been a while. Hi, the Flame. How you doing? I saw you were really active. Yes, recently I just saw your chats with Electricity about organic chemistry, and I'm in the mood to make a video on organic chemistry.
They haven't been the most fun chats. It's been more like me looking at it and going, this is obvious, how do I explain it? And then trying to figure out a way to explain it.
I honestly, the thing is, after these chats, I don't know the difference between organic chemistry and biochemistry at this point. I thought I knew the
Well,
difference. I thought the difference was organic chemistry is just chemistry of carbon, and biochemistry is the chemistry of things in biology. But then Roger went really in depth about oils and fats, and
well, that stuff I would say is more organic chemistry. It's just in like a biological context.
that's the part I don't want to make videos on, because this is just gonna be this will just end up as a video 20 minutes of me just listing different types of molecules. That's not fun.
Hmm.
I just finished a particle physics video with a lot of jokes, but this is organic chemistry. Yeah, this is going to be painful. Well, except for the naming convention. Naming convention is absolutely phenomenal.
You know, there was a paper that got published recently that basically disproves a fact that is stated in every organic
I remember
chemistry
that.
textbook.
Oh my goodness, I saw a meme about that a while back ago. But
Do you
I didn't
remember what it was?
no, I didn't understand the thing. I just know it was
Oh.
it like disproved something that was a given, and it was
Yeah,
hilarious.
it's like something they teach everyone. They're like, oh yeah, this is stable just because of this, and it's like everyone just assumes it to be true. And then you read the paper and it's like, oh, wait, why did we think it was true? And it's actually like
Wait, what is it then?
it's so weird.
What is the thing that isn't true?
Okay, do you know what a carbocation is? Type it in chat.
Carbocation. Yeah, if you type it in, maybe.
In the stream chat.
Carbocation. Does that have anything to do with a cation? Sorry, I forgot it's pronounced cation. Because it sounds like carbo and cation, but is it really that simple?
Yeah, it is that simple.
Okay, then yes.
Okay. Do you know what a tertiary and a primary and a secondary carbocation are?
Primary, secondary. Cation. No? I don't know.
Okay.
I just give up on guessing.
Let me just let's do the
Let's do the thing that we do. There we go.
Okay, where are we going? Close to the bottom.
I suppose. Yeah, that's the organic chemistry.
Yeah.
Oh no, wait, no, that's the
belongs in the depths of
PhD.
hell, I think.
Yeah, the bottom part has to be organic chemistry. The higher one, that's the PhD segment.
You have a carbon.
Right.
It's positive, so it's a cation. And it's bonded to some other stuff. So I will just draw. I don't know. I can draw it like that, and it doesn't really matter what it's bonded to. The main thing is that these are alkyl groups. Do you know what I mean when I say alkyl?
Carbon chain.
Yeah.
Okay.
Okay. And do you get why it's only bonded to 3 things?
Yes, because normally it would only be able to be bonded to 2, but it's carbocation, so it can be bonded to a third one.
Yeah. Okay. So I'm also gonna draw. Why is it red?
Do you really need a plus if you just have a carbon like connected to 3 things?
Yes.
Can't you just deduce that it's like if you have something like this? Can't you just figure out that right here you need it to be? Oh no, because it can be a single. I tried. Never mind. I didn't say anything.
Yeah,
Never mind.
because it would be a radical.
Yeah. Okay, never mind.
I mean, yeah, the thing is though, if it were a radical, we would draw a dot. But like, yeah, I don't know. We just have to draw it. Okay, so I've drawn 3 things here.
Mhm.
I'm sure you can easily tell what the difference is, which is just that.
Yeah,
some of them
first one is
got a
bonded to
hydrogen.
3 carbons.
Yeah.
This one 2 carbons. Then the third one only 1 carbon.
Yeah. Okay, so this is tertiary, this is secondary, and this is primary.
Ah, makes sense.
And
All right.
We draw like a degree symbol. I don't know why. That's just how we say primary, secondary, tertiary. And so in like basic organic chemistry, they're always like, yep, this one is way more stable because these alkyl groups push electron density this way, which stabilizes the positive charge.
Makes intuitive sense, certainly.
Makes intuitive sense. And then this one is slightly less stable because you have less electron
So
density.
for
stabilizing
everyone
positive charge.
watching who isn't familiar with organic chemistry, it feels wild I understand it so far. I gotta be honest, I'm really bad at this. But basically, for everyone watching, when you have a plus, that's obviously positive charge. Electrons have negative charge. Right here, when you have these lines, what this basically equals to is basically a chain of carbons, which all of them have their own little hydrogens at the end. If they're in the middle, they have 2. If they're at the end, they have 3. And basically, what's happening is right here, you can imagine it as our C plus in the middle being the positive, or rather the south side of the magnet, because I suppose it's south and north. And around it, we have the north sides of the magnet. And this one in the middle is attracting the ones around it, canceling each other out. Hydrogens don't have quite the electron density, I'm guessing, right? Because you said that right here, there's the electron density is coming more.
This is what was believed, right? And so this is what they taught us for years. Like every single textbook would teach this, and it turns out that actually these don't push electron density towards the car. And it's actually just stable due to some other random.
I don't mean to be that guy, but like, isn't the whole point of science that when you have something that makes intuitive sense, you want to prove it because in actual fact, because sometimes things which make intuitive sense turn out to actually not be true. Isn't that the whole point of science? How did this happen?
From what I was reading in the paper, it seemed that like it was kind of proposed quite early on, and it explained some stuff, and because it was so early on, people just took it to be true, and then from that point on, it was kind of just stated as fact. Like, not many people kind of looked back and went, hang on.
But isn't this just like such an organic chemistry moment?
Yeah.
With the thing is, I remember
the thing is, right, this is more stable than this, which is more stable than this.
Yeah, it's just that the explanation
is due to something completely different.
Yeah, it's just that the explanation was a completely, well, not I know, completely different thing, but it was just a different thing. It's so why did I cross out phosphorus? That's because these are just from an older live stream. I was basically asking like for purpose of different atoms. It's organic chemistry. That's my whole pickle with organic chemistry, is that a lot of it's in this unbelievably awkward spot when you can't apply quantum mechanics because it's too big, but you can't apply engineering because it's too complex and too small, and because you just end up in a spot.
If you ever apply quantum mechanics to an organic molecule, you're not doing organic chemistry, you're doing physical chemistry.
Yeah, right. And also, you shouldn't do it with most of them because they're just massive for quantum mechanics.
I mean, they do it.
I'm sending
we do a lot of the molecular orbital theory stuff with like fluorescent dyes and things. Like when you're making new fluorescent molecules, they tend to be organic because they have these big conjugated pi systems, and you end up using all that kind of orbital theory to work out the energy gaps that give you fluorescence and phosphorescence.
It feels so fun to me that I don't know much about organic chemistry, but it still feels so cool to me that you can say like a conjugated pi system and I get what you mean. Because this is actually one of the first live streams when you joined in, you explained benzene, the conjugated pi system. But I remember back then you asked me if I know what a conjugated pi system means when I didn't even know what an orbital is.
Slight oversight.
Yeah. Just constantly you were just assuming that I know things because they're so obvious to you, and I was like, oh yeah, I totally know what checks note conjugated pi system means. Hey, what does pi mean in chemistry? The thing is, gimmick is drawing bonds without writing all the elements. Atom is bonding is used only in case of carbon. As you can see, with a bond drawn like this, has to be a CC bond. Yeah, but in organic chemistry, it doesn't actually matter because that's what I love about this skeleton structure. It's great. It's absolutely. I don't know why organic chemistry can suck so much when it comes to the actual specifics of it, but it can be this great when it comes to the entire convention of molecules. Because it's genius, honestly, this whole skeleton structure thing. Also, I mean, come on. This has got to be one of the best not representations possible. My only pickle with it is that it may make it seem like I don't like the second one.
I don't like it either.
Yeah, because the second one loses the. Is it though? Is it? Because I really like this one because this one on 100% is the fact that you do need kind of double bonds, but on the other one, the only thing I don't like about this one is the fact that right here, it may make it seem like these are actual double bonds. But they are in the middle, so they basically, yeah, the resonance, they're not, yeah. It's such lovely. I love benzene so much.
I'm not a fan of the circle one, mainly because it doesn't like count bonds, right?
Yeah, I feel like the second one was just made to represent. It
shows delocalization, and that's about it.
It's almost like we need a whole new subject to study this. You know what I meant? I meant like as an approach. In quantum mechanics, you have the mostly mathematical approach, as in you create a model and then you don't even need to simulate stuff. You can do equations and then check with the evidence, and when doing engineering, then you just create the physical thing and then you use the maths mostly to check the physical thing. Thermochemistry. I thought the high composition meant high stability. But actually, what is the reason? Do you know? What's the reason for this?
I was reading it, but it was 1 a.m, so I was like, okay, I can't be bothered.
Wait, do you remember what the name of the paper is? Because I'll be honest, it would be hilarious for the video. What is zigzag lining? It was drawn straight, and then that kind of loses its meaning, and then we don't know how many of the carbon atoms there are being involved in bonding. I mean, oh, that would fix organic chemistry for me. If instead of doing the zigzag, you did a straight line, except there would be a specific distance for a carbon in that straight line, and then all organic chemists would just have to keep a rulers around to measure each thing. Oh yeah,
measure it in centimeters.
Oh yeah, I feel like if Satan could improve something in science, that's what Satan would do. I love that idea. You just have like,
it's also because the zigzags with like 120 degrees, that is how the carbons are bonding. Like that's the angles they're doing the stuff at.
I don't love trying to represent that sort of thing because it gives like a false sense of accuracy. Like I may be wrong, but isn't cyclohexane? I think it's also for benzene, but I don't know. I don't know. I'm not an organic chemist, so I'm just gonna go with cyclohexane. Isn't cyclohexane like if you look from the side, going like this, like it's not on the same height? Boy, yeah. I just tried to draw a cyclohexane from the side. I don't have the spatial reasoning skills required. Like,
let me see if I've still got it. Let's see.
Like this. There we go. That sort of thing.
It's like this. I've drawn it over here.
Oh, that's really good, actually.
They teach us how to do that. They're like, okay,
that's impressive.
Draw this lower one, and then you draw the upper one like this, with the corners slightly shifted. They teach you.
I mean, that's a shape and a half to like imagine in your head. I can do it. I have Blender. I'm just gonna do it in Blender.
Spatial reasoning really helps with chemistry because you can just rotate stuff.
Yeah, because you're dealing with spatial objects. That's one of the three things I mentioned. That's when I'm going to explain the video, one of the three things I will mention at the very beginning, which I think just explain everything about organic chemistry and clear up all the confusions, is the fact that atoms aren't actual physical objects. So, like, obviously it's going to be spatial reasoning because they really are in space. They really are physical things. So hold on, this one is higher, lower,
I have a molecule
lower.
Model kit where I can build it and show how that shape emerges.
Do they go up and down? Like every second?
They go up and down.
Okay.
Yeah, alternating.
So basically, I am really impressed that you drew it actually. Hold on.
Let's go.
Let me match the projection. You match the projection too. There we go. that is quite a shape to draw actually.
Let me see how many carbons I have. I've got 1, 2, 3.
Frame. Ah, no.
I'm about to take some from my other building.
There we go. That's... Is it also benzene or is it just cyclohexane?
Not benzene. You should be able to explain why it's not benzene.
Because of the because of the pi system? Was it conjugated? Did I get that right? I don't remember. Wait.
Not really?
Hold on. I can figure this. I thought that the pi bonds were sort of bringing it in place because otherwise they wouldn't click together.
It's to do with the hybridization.
Hold on. Because I don't know if I'm not explaining what my thought process was. I ain't a big town smart talking lawyer, alright? I don't know. Okay, so imagine this cylinder is a pi orbital. Don't mind the fact that it's lacking in the middle, right? Just imagine that in the middle it has the thing. Because I don't want to just set it up. It would take like 5 more minutes. I don't have the time. Who has the time nowadays? So imagine this is the pi orbital, right? And then I thought that it was because if you arrange them in a hexagonal pattern like this, then if you try to move every second one lower down, then these other ones will basically pull them up.
You're completely overthinking it.
Don't
worry about what the pi orbits. Focus on the geometry of the carbon.
Okay, I gotta say this. Is it because of the hydrogens?
Huh?
Is it because there are 6 hydrogens of 12 as a clue? Okay, never mind. I just realized how dumb. I just realized how dumb my question is. Is it because of the 6 hydrogens? Yeah. As if isn't the entire difference between cyclohexane and benzene? Benzene is flat.
I'm building benzene, by the way, with my.
I just realized how dumb my comment was. It makes intuitive sense, but I don't know why it makes intuitive sense to me that benzene is flat.
Okay, can you tell me... Whoops. Okay, can you tell me in...
Oh, one more guess. I'm sorry that I keep interrupting you. No,
it's fine.
I just have the aha moment right when you start talking. Is it because each carbon is bonded to 3 things and they want to be as far apart as possible, but they don't need the third dimension to be as far as possible? So when
You're very close.
So when carbon is bonded to 4 things, they need to all point in different directions. But when carbon is only bonded to 3 things, they can be bonded on a flat plane, because this is already as far as possible. And
you've basically explained it, but completely avoiding hybridization, which is like you've like reverse engineered hybridization.
I don't like hybridization. I don't like it.
Why not?
Which is because I have PTSD when I asked you, why carbon hybridizes exactly for organic chemistry, and it turns out that organic chemists just kind of go with it, go with the flow. They're like, yeah, carbon is hybridizing.
I don't really know the answer for that.
Yeah, I have PTSD. I mean, there obviously probably is kind of an answer, but the fact that, the basic understanding of organic chemistry means not knowing why is terrifying me. Because my autism won't let me just not know why. I need to. Wait, okay, so what's the answer? I won't interrupt you this time.
Okay. Can you draw an sp3 hybridized carbon?
sp3, that's 1, 2, 3, 4. Okay, yeah, I can do it in Blender, because I feel like in Blender would be better.
Sure, yeah.
Wait, I hybridized carbon. You want me to draw not the molecule, only the electron cloud?
Just draw where the bonds are going.
Well, metabol. There we go. sp3, it would look like this. I don't know. I don't remember the angle exactly, but
you don't need the exact. You need to know the shape.
And let's just pretend that they're all at correct angles. There we go. This sort of thing.
Yeah.
Because I remember that they are all as far away from each other as possible.
Yes. And can you make an sp2 hybridized carbon?
Yeah, it's gonna be the same thing, except it's gonna be flat and only gonna have... there we go. So sp2 would just be this way, simply because this way they are already as far apart as they can be.
Yep.
Like if they go in up or down, then they're gonna actually be closer.
Yep. And when I tell you, if I say, okay, a carbon is bonded to some other stuff, but it has a double bond in one of those bonds, can you work out whether it's sp3 or sp2?
Let's hypothetically say that someone watching the live stream didn't understand the question. Could you rephrase it for them?
Okay, it was a bad question.
To be fair, I'm not an organic chemist. I'm not exactly easy crowd for
okay.
you.
No, so if carbon has a double bond,
Right.
that means it's only bonded to 3 things.
Yes.
Right? Okay, so that means it has to be sp3, sp2 hybridized.
Right.
Okay, so now can you look at benzene and cyclohexane and tell me which one has sp3 carbons and which one has sp2 carbons?
Well, obviously, cyclohexane has sp3 because each carbon is bonded to 2 carbons and 2 hydrogens, and benzene has sp2 because each carbon is bonded to 2 carbons and 1 hydrogen. So benzene has sp3, and I mean benzene has sp2, cyclohexane has sp3.
Yes. And now that you've established that and you've built the shapes, can you see now how benzene can be flat?
Yeah, it even has to be flat because in order for them to be as far as possible, they only can do it. They have to be flat, so that the angles are as far as possible. Okay, I get it.
Can you also understand why cyclohexane has to be zigzaggy?
Yeah, because it's bonded to 4 things, which means if it were to be flat, then the hydrogens would have to be like awkwardly right next to each other, like this sort of thing.
Yes.
Sort of awkward thing, and they wouldn't like it.
You'd be squishing it, and
I
molecules don't like to be squished. They can squish, but they don't like it.
I really get why a while back you mentioned that a video about organic chemistry would be great because I could visualize the orbitals. I get what you mean now. It does make... It is so obvious when you really put it this way. It really is great.
It just takes a while to get there.
Or just takes like a way to visualize it. I don't even think a while. I just think it's a matter of visualizing it. Because once you realize that they have to be as far away as they can be, then you can tell that benzene has to be flat. Remember sp3 tetrahedron 120. I think it's mathematics at the end of the day. Haha. Get owned, liberal. I'm glad I was careful.
I've actually made the cyclohexane. Take a photo.
Oh, hell yeah.
It took a while because I had to stick all the carbons on it.
Just having a professional chemist is always so weird because you just have like mod. I thought it was a stereotype, but no, apparently it's a real thing. You do just have like models lying around ready to be the atomic things to make models with.
I mean, I only got this one last year. Was it for my birthday?
That's actually such a cool gift.
My mom was like, "What can I get you?" And I was like, "Maybe one of those model kit things." Okay. So the interesting thing with cyclohexane is that zigzag shape isn't the only shape it can actually be in. But I will send you this.
Oh, well, I'm assuming you need energy to... I'm assuming that's the most stable one, but do you mean like, is there an excited state of cyclohexane?
I wouldn't call it excited, but it's slightly higher energy.
I don't know the naming convention. I'm just going to... Can I show it on stream, by the way?
Yeah, sure.
Alright. Always important to ask for consent.
Doxing my hand.
Hand reveal, everyone. Oh, it's hand reveal. Alright. Wait, so... But it is kind of like an excited state. I don't know the names, as I mentioned. But you have to talk with me in the theoretical chemistry language, because I don't know organic chemistry. You have to translate. You have to translate the quantum mechanics. I'm the guy to ask the question, but what level of chemistry are you guys looking into? Is it postgraduate? studies like university studies. Well, Flame is. Well, the thing is.
Yeah.
Actually, you know what? Go for it. I don't want to put any words in your mouth. You can just.
I'm doing a PhD next year.
Yes. So Flame is a soon-to-be doctor. Ah, that sounds so
soon
cool.
Meaning in 4 years, yeah, if that's what you want to call soon.
I think of it as soon because you're basically one step away from becoming a doctor.
One step being an entire PhD.
Okay,
project,
yeah, but still consider like,
and also
everyone
graduating.
else
I have to
on the
actually
planet.
graduate with a master's.
Yeah, but like consider an abstract distance to becoming a doctor of everyone on the planet versus you. You're really
I mean,
close
I
to
am
being a
closer,
doctor.
but like, it's a long way away.
I don't think it's a long way away. You'll see. In 4 years, I'll be like, see, told ya. You're soon to be Doctor. Well, then I'll call you just Doctor Flame. Such a cool oh my, I'm sorry, but I just... Can you imagine, like, 4 years, you joining on stream and you be like, Doctor Flame? That's such a flex. That's such... To have a title doctor, it's really awesome. So yeah, Flame is basically soon to be a literal doctor, and I am looking into IUPAC, which is basically the most... about as basic as you can get with organic chemistry. I don't think there is a wildly acceptable source that's more basic than IUPAC, simply because IUPAC is just the naming convention. Does this help with paying the bills? Yeah. Organic, I mean, to some people, it helps me with paying the bills. SP3 looks like a tetrahedron. I feel stupid for not realizing it sooner. It's actually really cool that you can just think of it geometrically. It's really nice. It's really nice that it's large enough for it to actually be a physical thing. Wish this was taught in Blender in school. I agree.
They tried to teach us using augmented reality, because the professor who was teaching it, he had like a PhD student who was doing like chemistry education, and his whole project was making this augmented reality thing.
Well, that's actually great.
You would point your phone at a code and it would pop up with a molecule in 3D and you could like rotate it. But I thought it was way too gimmicky. Like, yeah, I don't know. It felt like too much of a gimmick.
Having your own professional chemist is certainly a flex. Yeah, the thing is, you really are, as in the titles, I've been calling you a professional chemist for a while because that is what you are. I can't call you...
Right now, I'm not getting paid to...
I don't think a professional chemist, like, you have to actively do professional chemistry to be a professional chemist. Because you're not it's not that you're finished with being a professional chemist. You're basically... You have a break in being a professional chemist.
Well, it was more that I got a taste of it because it was an internship, and then I'm going to actually do a PhD and get paid.
Yeah, exactly.
I don't know if a PhD should even count as professional, because you're getting paid by a studentship kind of thing.
I don't know if PhD should count as professional. I don't know if PhD should count as professional. It's certainly a quote to live by. I'm not a professional chemist. I'm gonna be a doctor in like 4 years only. Come on.
Yeah.
So wouldn't you, Dog That Can Explode? I mean, come on, doctor. I have so many teachers, by the way, in my videos saying that they've shown my videos to their students, and I feel...
That's really nice.
I feel so weird, honestly, because on the one hand, it's an honor, it's a massive honor to have a teacher be like, yeah, your material is so amazing that I'm going to show it to my students, but at the same time, I remember being a student, and I don't know how much I've changed since then, and so it feels weird. Like, I don't know if I'm the right person. I did find out why 9 parameters vanish when using color rotation. Oh, Beardman. That is... wait, what do you mean you found out why 9 of them vanish? Because I know the reason why 9 of them vanish. It's because the matrices are constrained to basically be the Lie algebra. Oh my god, it's not the Lie algebra one. It's because they are constrained to being only rotational, and also determinant has to be, I think, 0. So basically, they have some constraints on what they can be, but I don't know the specifics because the specifics are too advanced for me. So what's your major, make it, if you don't mind telling us? I have told you all before, and at this point, honestly, at this point, it feels like you are all just making fun of me, and I don't know if I appreciate it. Like, people asking me once or twice what my major is, I get it, but asking me every single day what my major is, especially when in a voice chat with someone who's doing a PhD, that feels like an insult.
Not yet. Next year.
I don't have a major, Flame.
You don't need to.
Yeah, but it feels like an insult. Like, just, you know, it feels like you're at family Thanksgiving and, you know, you have your cousin or whatever telling about, oh yeah, I cured cancer, I got a Nobel Prize, and so on and so on. And then, you know, everyone just turns to you and is like, and what have you done this year?
But I think it speaks to your level of understanding that
it does.
People will come in and assume that you're like at least.
Oh, you mean
student.
this way? Oh no, I thought you meant like, oh, not having a major is your level of understanding because you don't know much. I thought that's what you meant.
No, as in the fact that people assume
it is nice
that you're a student or something.
It is nice.
It does kind of indicate that you've done pretty well without actually studying.
Well, I have studied.
Yeah,
it's not that, like I haven't
studied at a university.
I haven't studied in a way that's actually specialized. Or in other words, I haven't studied. I have studied as in researched, but I haven't studied actually. In comparison to how students study, I haven't done that. Simply because, well, I ain't a big town smart talking lawyer. You're not having to learn for a long time. Oh, talented student thing. Yeah.
It took me a long time to like figure out how to study.
It really
I was very
is.
bad at studying.
It really is odd because when it's always you have to figure out how to study something that you're having trouble studying. That's the whole point. If you have something that comes really easy for you, then you don't need to learn how to study it because it will just come easily. So it's always the most annoying bits.
Like, in school, I didn't learn how to study because I found a lot of stuff quite easy.
Yeah, I had the same.
And then like as it got more and more like memorization heavy, I was like, wait, I actually don't know how to study, but I need to. And then I was freaking out.
And then you have two paths in life. You can either take responsibility and, you know, learn how to study things which are still tough, or you can ignore things which are tough and become a YouTuber. You have two ends of the spectrum right there.
Well, I mean, I ignored it and then got a C in chemistry and then kind of snuck my way into a chemistry degree anyway by complete luck. And then only in my second year, I actually figured out, like, oh, I need to study. This is how I study.
Can you imagine you in 4 years, like talking with you back when you were getting poor grades in chemistry, you know? Oh, wait, what was the grade? Was it C?
It was a C, yeah.
Yeah, like you getting a C and future you were just coming, oh yeah, well, by the way...
I knew I understood it back then. Like, I understood stuff. And in lessons, I was the kid with my hand up all the time, just like answering questions and asking questions just constantly. But it was just
I get what
in
you
exams, I just couldn't perform. I didn't study.
I remember recently when I started getting into chemistry, it felt so much different than back when I was school. Well, back when I was school, I was failing chemistry constantly, simply because one thing which always confused me was ions. That's because in my mind, back when I was at school, I couldn't wrap my head around the fact that ions even existed. Like, if you have a positive ion, then how could it be positive? How can you remove an electron if the whole point of an atom is that it has the protons and electrons? And schools in schools they always just taught me to like memorize the fact that ions exist and that ionic bonding is a thing or whatever consequence. But I honestly, it took me years, literal years, to get back to chemistry and be like, oh, yeah, ions actually make a lot of sense. If you just don't think of atoms as black boxes, you have to memorize only as things that, actual physical things that exist based on underlying particles. So we take a matrix and you transpose it and complex conjugate it, and the multiple has to be 1. You didn't go the pain quantum mechanics homework so much. Yeah. Make it is great and has narcissism, so he sounds like he knows his stuff. That is true. I just have an ego on me. I just sound confident. I'm not confident, but I just sound confident. That's what matters. That's what matters in science. You don't need to check your claims if you just say it confidently enough. I'm just making shit up all the time. That's how science works. I mean, to be fair, you did join in on stream with this exact thing happening. Someone
Yeah,
just
I mean, this is
confidently
really
stating
happen.
something.
Like, it was such an outlier. Like the fact that this is in every.
That's what's so funny about this, though.
Taught to us specifically.
That's what's so funny. That's what sucks so much about. Oh, I don't remember what the name of the research was. It's a certain kind of research where instead of researching something new, you're rechecking previous work. That's the kind of research that happens extremely rarely, simply because no one sponsors this sort of thing.
Yeah, because science it usually builds on itself. You don't go back against old science.
Yeah, and the problem there is that we don't actually know if this is a rare occurrence. It could happen all the time. Before this paper, this was considered to be an obvious fact. So it could happen way more often than in psychology. I remember that's a genuine problem where there are a lot of I think it was psychology. There were a lot of poorly written papers, but no one will sponsor just the research into things that have already been researched, just to double check them. And because of that, there are just mountains of studies which we don't know if they're valid or not. It's a genuine thing. It's unfortunate. Dr. Flame drop kicking past Flame for getting a seed at one time.
I mean, I would have ended up at a better uni, but that would be it. And to be honest, I've secured quite a good PhD project considering the uni I'm actually at.
I mean, the uni you go to, it's only for flexing purposes, isn't it? Just to be like, I went to Harvard, right?
Yeah, pretty much. It's like along the way, whatever you do will like enable the next step, but that's pretty much it. And so it's like your grades in school will enable a uni, but once you're at uni, they don't care what your grades at school were. And
also, once you become an actual professional, I've never seen, maybe it's just me, but I've never seen an actual professional being treated in any way differently because of what uni they went to.
Yeah, exactly. And it's like, for me, once I do the PhD, then it will matter where I did the PhD at, but it won't matter where my degree was at. And so it's just as you go up, it's just the latest thing is like how you're defined.
Which makes sense.
And so one thing enables the next thing, but people jump around or downgrade or whatever. It's not.
That's why I really don't want people to give up on, because that's also a sentiment I really have to get. Fortunately, I get in a very positive light in the comments when people say that, oh, I've hated mathematics or something, but after watching this video or after watching your videos, I began to like it again. That's the thing. You don't need to be at any point in your life to.
Yeah.
Like going to Harvard would be nice, I guess. I don't know. I've never been to. I'm not posh. Going to Harvard would be nice, I guess. But once you're out of Harvard, the experience won't really matter. I guess there are some opposites to that one, but you should help your students understand, not memorize. Yeah. I was about to say that the pick of organic chemistry is that you have to memorize, but that's not even true.
I mean, even in the channel, like these questions that have been going on, is like some of it comes from these rules, but most of what I'm explaining is like how these concepts work and how they fit together. Right?
I just don't know.
I'm not actually making electricity memorize anything.
I mean, I know. I read them. It's just that when it comes to, that's my pickle with videos, is that in organic chemistry especially, I don't know where to go with it exactly. I don't know what direction to go in. So that's my biology problem. I don't know how to make videos about biology, because if I was going to make a video about the cell, for example, the only thing I could do is list organelles. That's all I could do. I wouldn't go in depth in any interesting way. I could just list them, which is just memorizing. There's nothing too interesting about that. But I guess that might be just my skill issue. I just need to get into it better.
I think biology is a lot cooler once you know the chemistry that works behind it. But the problem is,
I think
the further you zoom out, the wider the understanding becomes.
I
Either
think
way. So let me draw a diagram.
I think medicine is cooler if you understand the biology behind it. Biology is cooler if you understand the biochemistry behind it. Biochemistry is cooler if you understand the chemistry behind it. Chemistry is cooler if you understand the physics behind it. And physics is cooler when you understand the math behind it. That's why I'm starting with math. One day we'll get to medicine. 7 years or something.
I'm gonna draw a diagram, which is like levels of understanding, and it's like. So I would say horizontal on this is like things at the same level, but the wider something is, the more things you have to remember at that level. Whereas the deeper down something is, the more you have to understand behind it. Like you're building on the fundamentals, right? Does this kind of make sense? It's a really weird way.
Can I hold on? Can I show you something? It will be on stream. Hold on.
Sure.
Let me just. Would you mean something like? Hold on. I'm forgetting. I'm forgetful stuff. It happens at my age. I need to remember. I think it was this one. So you mean like a cone like this, where you start at the most basic things, but then as you increase in scale or abstraction, whatever you want to call it, then there are more things at the same level of like complexity and
Yeah.
yeah. Now that's wild.
Much, yeah.
I've never
Yeah.
heard about it being discussed this way. Actually, that's one new thing.
And it's like, and so, okay.
Okay, first of all, I do want to answer Deep Guy because Deep Guy asked me a while back.
Yeah, sure, yeah.
Still make it. You didn't answer my question about my major. I don't have a major. that's why I joked because I don't have a major, and yeah, I am just a random guy on the internet, as I mentioned before. But I always call this concept abstraction. So basically, as you go on to higher scales, you abstract things more and more. So it's still the same underlying mechanics, we just abstract them to make them simpler. So with each level of abstraction, you gain simplicity, but lose accuracy.
Yeah, and it's like, this scale can go on infinitely, but let's just say biology is at the top here. Biology is quite wide, but the depth is a lot less than like physics and chemistry, where it's like you can delve into some of these levels, and there will be things at certain levels, and some things will have branches that go deeper. But generally, you're not going past chemistry, and chemistry is then a bit thinner, and it has a lot of room for depth. But you've also got quite wide bits, and then when you go all the way down, you have physics, which is like there are different parts of physics that
the smallest one
depth.
is particle physics, because at that point you're only dealing with 4 fundamental forces and 17 particles, which is, well, quite tiny. Yes, basically this is a combination. So the way, that's always how I see it, where basically you increase in scale, but you also have to narrow in.
Yeah.
So
it's a very like broad way of summarizing it, because there are topics in every single science where
the highest one, the highest level of abstraction I always go with is economics, because it's the most abstract field I can always think of that everyone knows. It's always economics. So basically, economics can be explained using medicine, but medicine can't be explained using economics. Medicine can be explained using biochemistry, but biochemistry can't be explained using medicine. Biochemistry can be explained using chemistry, but chemistry can't be explained using biochemistry. Chemistry can't be explained using physics, but physics can't be explained using chemistry, and so on and so forth. The underlying things always explain the further ones, but the further ones are less specific. And the other ones... Am I thinking capability is not at par with the others? How can I realize my dream of becoming an astronomer? Getting excited how my customer could answer problems of organic chemistry so much faster than I can. I was like, what am I not getting that they obviously are? I don't know. I was always a quick guy to answer questions, but at the same time, I was really slow in other cases. So I don't think it's as simple as just being quick with answering questions. I think it very much depends on the kind of person and the kind of question. So I don't think
most of the time, for me, the classmates who could answer the quickest were the ones who would just memorize everything.
Yeah, that's another thing. Yeah,
understand a lot.
The thing is, Harsh, you shouldn't compare your thinking. I've already mentioned it. Oh, I've really gone this rant before too. How I think that's idiotic to measure intelligence in IQ. It's such mind-numbingly idiotic to me. That's a whole other thing. Don't think of other people as smarter than you. I know it sounds corny, but also it's scientifically accurate to say that it's everyone is smart in their own way. It sounds really corny, but human brain is the most complex environment we've ever seen. You can't just summarize by saying one of them is better at thinking or something. We don't even know how thinking works. Philosophy is the behind every science. Well, it's also unbelievably vague. Memorizing. Programming adage I quite like. Learn one level less abstracted than what you normally use. Oh, to understand, I like it. Well, acronyms, I use C, which is the least abstract language out there, except for maybe assembly, but come on. Actually, no, it's actually on a similar level. And I also use assembly, so I know machine code. Time to do medicine of elementary particles. But that's the thing, you technically could. Is that right now we don't have the tools for it. Neuroscience exists. Yeah, I consider it just a subfield of medicine. Can you ask Flame how he learned to study? I wrote a C in math, even though I completely understood the topic. How did you learn to study, Flame?
Just... I mean, realistically, I had to just sit down and do anything rather than nothing. And I had to put myself in. So for me, my trick is just going to the library, because then I can't do anything else except do the studying right in the library. But in terms of like what I was actually doing, the main thing for me is doing actual questions that are going to be on exams or whatever. You do the questions, and it makes it extremely obvious where your gaps are, and also then reinforces stuff you do know and stuff that you figure out to do the questions. So say you do a question and you understand it, right, and you know it really well. When you do that question, your brain is recalling the information and it's going through the process of working out stuff. And then once you've done that question, your brain goes, okay, that information in my memory was really useful. I'm going to hold on to that information. And so that reinforces your memory of it. But say you find a question that you don't know the answer to, you then go and find the answer and you piece together the answer based on these pieces of information you find elsewhere. Then your brain goes, okay, this new information is really useful, and so I need to hold on to that. And so it's really just, if you trick your brain into thinking the information is useful by actually using it, then you will remember it, because that's what the brain wants to do. It wants to find what information is useful and hold on to it, because it knows that that's how memory should be used.
Yeah, so two things. First of all, acronyms, you said you do use abstraction within C though, like print and such. Print is a function, you can call it from assembly, you can remove all abstraction and you can still use print. And second of all, you answered extremely specifically to studying. I, however, can give also a piece of advice for how to, because here's the thing. The method for studying, I can't speak on that. I ain't a student, I am just a YouTuber. However, forcing yourself to do something you have to do, that's something I'm quite familiar with. And that is the actual trick to whatever you want to achieve. You have to force yourself to do it.
Yeah.
You have to realize that if there is something you should do, you're not doing, that means you probably don't like doing that thing. Maybe it's in your subconscious, maybe you realize that you don't like it, you simply don't like it. So you will go to any lengths to avoid that thing. You need to really force yourself.
Yeah.
What I do is I really often just start streams to work on stuff. And that helps because then I'm up peer pressure, I guess. Also, in the past, I also used to go to the library to script some of my videos when I wanted to remove everything from my environment. I just have a laptop with nothing on it. It can't handle anything other than a web browser, and I just use that to script videos.
Mm-hmm.
Really is great.
And another thing with forcing yourself is that as you so you have this like barrier, right, that it's like activation energy in the brain, where it's like it wants to do the lowest level energy thing, and you have to give it energy you have to overcome some kind of barrier to get to a higher state where you can, where you're doing work or whatever. But as you overcome that barrier more and more, the barrier lowers because the brain then gets used to you actually taking control over what you're doing and not autopiloting on the easiest thing. And so the barrier does lower, and it becomes easier and easier to do productive stuff because you're used to deciding to do something productive.
Yeah, and also another thing too, that's you need to because there's a psychological thing I had to also get over, which I find a lot of people have. I call it the new year, new me problem. So basically, really often people look for an excuse to get started on something. New Year's resolution being the famous example. But that's because you need some sort of excuse to get started on something, because if you don't need an excuse, then you realize that you could start that thing any day, and then you realize like how much time you've wasted when you could have actually been doing that thing. So the quicker you force yourself to do something, that's why if you don't do something for a long time, like for example, if you take a break studying for like a week for no reason, then after a week you'll have trouble getting back into it, because the entire time you'll be thinking, oh my goodness, I could have studied this 3 days ago or 4 days ago or 5 days ago, and still I'm doing it right now, kind of like I'm doing with the video, which I'm already 2 days behind on. It's fine, I can make it though. It's gonna be a quick one, I'm not worried. You shouldn't force yourself, you should find your passion. Whilst I do agree you should find your passion, there are a lot of things that in the short run suck, but in the long term are great.
Yeah, many times you have to force yourself to do something you don't want to do in order to do something you do want to do.
Yeah, there are a lot of things...
Like a degree.
I keep Actually, you know what? I keep going back to the things that are so highly specific to me that not many people will relate to. But for me, there are many parts of the video making process which just suck, but I still like them simply because at the very end I'm finished with a video, and I like the videos. So I do have to force myself to do them.
And for me, I just want to do science, and so sometimes I have to put up with...
You just want to shoot lasers.
Or essays that I'm not super interested in.
You just want to shoot lasers at space rocks.
I just want to shoot some lasers, yeah.
Also, oh yeah, you reminded me, that molecule you've mentioned, hold on, which science was it in?
Yeah.
The iodine fluoride and fluor? Iodine, I and F ones.
I think it's iodine hexafluoride. And
that looks vile. It
doesn't really want to exist.
Yeah.
But I'm making it exist anyway.
It doesn't really want to exist is the perfect sentence I was looking for. It looks like you're just honestly trying to troll someone.
Funny thing with fluorine is you can kind of just stick it on anything. it just sticks because it likes electrons so much.
This doesn't look like a real molecule. That's not there is no way that's a real molecule.
Yeah, so remember, iodine it starts with 7 electrons. So we're just adding a bunch of extra ones. I haven't really studied it.
Wait, is it really... Hold on. Is it really that brute force? Like, with a... Oh, no, wait, that's a minus. That means 8 electrons. Oh, never mind.
Plus every electron in these bonds, right? So 8 plus 6.
This is...
So you've given it 6 more electrons than it wants to have.
Imagine someone passing in school their chemistry grade just by memorizing stuff, and then you show them something like this and ask them, oh yeah, why is this a thing? There isn't a single...
I was showing my friends because they were like, oh, what research are you doing? Because they're doing like organic chemistry or like analytical chemistry. And I'm like, oh, I'm studying this. I just drew this. And they're like, what? I said, yeah, it doesn't really want to exist. And they said, you don't say. The thing is,
you know what it looks like?
Theoretically exist in space.
It looks like the kind of question that I would ask you, like, oh yeah, flame, but technically could it exist? That's what it looks like. This is helium hydride. This is neutral helium hydride, except with bigger atoms.
But the thing is, I make this with the plasma stuff. I just I just zap it hard enough and it makes this for a short amount of time before
It doesn't want to
disintegrates.
exist, but it will exist, alright?
I will make it exist.
You will make it exist.
And I'm also doing this one, which is just...
I mean, after the hexafluoride one, the second one feels like a tamer version, honestly.
Yeah. Negative. I've already made IF minus, which is not very impressive. I'm trying to think what else. I'm basically doing a bunch of stuff with halogens. So iodine, chlorine, bromine, fluorine.
Lasers boring. What about hadrons? Actually, the thing is, I also really like lasers, but I love them for a wildly different reason from flame. Because you love them mostly because of like light in chemistry. You just like a light in chemistry.
I like the way light interacts with molecules.
Yeah, the reason why I love it is because lasers is basically the purest form of energy you can have, except for like gluons or gravitational waves.
Because it just lets me add energy to a molecule. Like
Yeah,
it's literally you just add energy, any energy value you want. You just add
Exactly.
it to the molecule,
It's so mad too. You can just have. This is basically an energy beam. Lasers are just an energy beam. From a physical point of view, they are as close as you can get to an energy beam, which is comical if you think about this. The more you think about how complex of a topic energy is, what it is exactly, how you have radiant, thermal, chemical, gravitational potential, all these different energies, and then you just have a laser, which you can use to excite electrons. Oh, what are excited electrons? Don't worry about it. They are just electrons with more energy. What do you mean what are excited electrons? They just have more energy. Oh, in what form do they have that energy? They just have energy, chemical, alright? Stop asking questions. Everyone should know what the wrong because there's no perfect. Yeah. My chemistry is so bad. I like no idea why it doesn't exist from a glance. Oh, I guess that is like a sixth sense that you get in any field actually of science when you can just tell something is a certain way at a glance.
Yeah.
It's basically because, well, I can explain my reason for why it looked just made up to me. Basically, Beardman, this is going to be a massive oversimplification, but in chemistry, you have a lot of atoms which are nice. They are well behaved. They form stable molecules. They're solid. They like other atoms. The best example being hydrogen or carbon or oxygen as an oxidizer, or metallic, all metals, but mostly only water metals. So that's a bit rarer. I'm trying to imagine the periodic table in my mind on the right, and I don't think anything under hydrogen actually behaves nice, doesn't it? Basically, fluorine. I can't speak for iodine, but I know that fluorine, in these quantities, I haven't seen it often, I'll be honest. In these quantities where it takes up, what is it, 70% of the molecule? 80% of the molecule?
Have you not heard of PFAS?
PFAS, maybe.
Polyfluoroalkyl substances.
I know what it means.
Can you draw one?
Polyfluoroalkyl alkyne substance. Well, alkynes, I'm assuming carbon and F. I don't know.
Alkyl, not alkyl.
Alkyl. Oh boy, alkyl. Hold on. I give me a second. I'm entering my mind palace. Kyle. So, I'll. That would be methyl. I'm trying to imagine anything with "il" on the end to get.
Okay. Alkyl includes methyl, ethyl.
I mean, yeah, methyl. I got that. I just don't remember what methyl looks like. I'm assuming it's going to be a certain carbon chain with a lot of fluorine in it.
Yeah.
Okay. Hi there, Remco. well, if it isn't the graviton hater.
I saw that in the
you
video.
graviton fanboy. Oh, how about... Oh, well, you fancy you joining the stream? I'm surprised you're not too busy trying to prove your made-up particle. Oh, I'm sorry, I can't hear you over all the gravitational waves. I specifically posted the screenshot. I really hope you're not upset, Remco, because I specifically posted the screenshot from the video with the Suck It Remco in the corner, and I was really hoping that I conveyed the message that this is going to be in the video well enough. Apparently CCC is possible. Well, technically everything is possible, Acronymus. I always use helium hydride as the example, simply because atoms separately have an insane amount of potential energy. So technically, okay, I don't know if actually every, but technically, practically every molecule is possible. It's just that really often you need it to be the only molecule in existence. So 3 carbons. I actually don't know. Hold on, 3 carbons. Doesn't feel too stable though. Because when you have carbon dioxide, you do have, I don't know, just COO. You do have oxygen to oxidize on both sides. So in this case, it would be the opposite. I thought it was a joke at first. You joke now, but wait until we find out beloved Titan particle. Honestly, I would dig it. If Remco discovers the graviton just to spite me, I'm all for it. Can you imagine having a Nobel Prize winner with the whole research just motivated just to spite a random YouTuber?
I would really like to collaborate with Remco if he goes into academia.
And also,
I don't know how, but some kind of collaboration between both our PhD topics.
Yeah, and also Reblax is also in the. That's gonna. You're actually all on similar levels, aren't you? I don't know. I'm not.
I think Remco's got an extra year left. Oh, actually, wait, Remco, where are you at right with your? Aren't you applying to PhDs now? I can't remember. I basically got really I should be applying to them at the moment. Like I should have applications out right now. I just got really lucky that
you just actually got the deal.
Like, oh, actually, I'll just accept you. Master first year. Oh, you got 1 more year on master. Okay, yeah.
I see. I don't remember where Reblax is though. It is mad, by the way, to be. It's the thing is, I dig the science community so much. That's because no matter the field, everyone is such a massive nerd, and I absolutely love it. It's great. The thing is, the way people can be passionate about something like, you know, the triplet state, for example. Wait, did I get that right? Triplet state, or I don't know, coupling to the Higgs field, or Lie groups. It's mad. I absolutely love it. It's such a powerful form of energy. Reblax and me would be an insane scientific combo. That is true. Remco and Reblax, I think it's because both of their names start with RE. That's honestly my take on it, but Higgs potential for the win. Higgs is so great. Oh, Remco, now that you're here, you could actually rate my explanation of the Higgs field I did on the beginning of the stream. I basically explained it with... This is actually kind of speaks for itself. Where basically, you know, you have a lot of energy, this causes a lot of mass, but if you have little energy, then you still have mass, so you need the potential mass in form of the Higgs field. How would you rate that explanation? I'm trying to understand Higgs. Higgs, it's so cool that... Why are you ignoring gravity? Well, it's because poor graviton. I'm not ignoring it. I just don't want to waste time talking about things that aren't real, Remco. I prefer to focus on the real science. Like relativity.
Like iodine hexafluoride.
Like iodine hexafluoride. That's real.
That don't exist on Earth.
It is so funny that
make them exist.
I love how, by the way, it is called astrochemistry, but in reality, the astro isn't it's basically just unstable things. It's not really astro.
Kind of.
Because astro...
It does inform about what's going on in space, because it's like, if this can exist, then stuff from this can exist.
Yeah, but correct me if I'm wrong, but isn't the whole point of astro there, like, extreme circumstances, under extreme circumstances, like
Yeah.
extremely high radiation or extreme vacuum or stuff like these. Because it really feels like just unlikely molecules. And saying that they can exist in space is like, yeah, they can exist in our universe. That is the bar there, isn't it? That these can be somewhere in our universe out there. Astrochemistry people are wild. That's what makes it so fun, actually. Electrons get me excited. Zucker and Cox did a research project together just because of their names. It would be an insane form of collaboration, though. Theoretical chemistry, particle physics, and mathematics. These fields aren't that far away from each other. Tefta had this thing, with Delta Robotics, and I find it so cool. Delta Robotics, they have basically 3 people, where, if I do remember correctly, I may be wrong, but 2 of them are engineers and 1 of them is a doctor, a medical doctor. And so they basically build prosthetics. Well, kind of, not quite prosthetics. Yeah, and I find it so awesome to just have that kind of power team.
Yeah, to just mix between...
Absolutely love it when different fields collaborate in a perfect synergy way. Thou shouldst have to prove that best rates of development of human history have all been out of spite. I don't believe that, Harsh, actually. I really want to dispel that myth. That's a myth. The thing is, the reason why wars furthered our understanding of science so much isn't because there were wars, only because there was a lot of money that was wasted. That's the actual pickle there. The thing is, wars are just these moments in human history where we have extremely large amounts of money with people who don't care about getting returns on that money. If right now we spend as much time as we spend during wartime, except instead of killing people to sponsor research, then we would be centuries ahead. And I really want to dispel that myth. We don't need another world war to further our research. We just need to give scientists more money.
I'm not sure that just give them more money is the solution.
Yeah, but you get what I mean.
Right now, a bit of a state is that, like, a lot of scientists have to do things that will get money over other things.
Yeah, that's
so,
what
like,
I mean, like publicly funded research. So research that isn't made for the sake of getting returns on it. Isn't made for the sake of profit, only isn't made for the sake of monetary profit, only is made for the sake of, well, the return on investment being the research that's being done, the science, not any money that you can make from that science. That's at least my take. I'm applying masters next year, but don't have a strong astrochemistry on uni. Wait, check. What are you applying for?
My uni doesn't have any astrochemistry. It's just this one professor who does physical chemistry does a bit of stuff with astrochemistry applications.
Also, I feel like astrochemistry isn't a field of chemistry like organic or inorganic. It's more like an application.
No, it's a very, very small field.
Yeah,
it's more like a category of molecules, to be honest.
Yeah, that's what I'm saying. Yeah, that means like... Never going to say medical.
And it's not very useful chemistry, like, realistically.
I mean...
it doesn't get funded very much.
I don't feel like... Well, there is... Okay, those are 2 different claims.
Well, they're kind of not, though, because what people consider useful are what gets funded, right? Like, if something...
Yeah, but also what people consider useful...
research is always going to get the most funding.
Yeah, but also what people consider useful ends up not being what's actually useful.
Yeah, that is true as well. But realistically, if you discover that some molecule can exist...
I mean,
2 billion light years away, it's like,
yeah,
okay,
but
how useful is that?
The thing is, though, the way our technology progresses, I feel like in 100 years, the research on molecules that are wildly unstable is gonna matter a lot more, simply because that's usually the way technology goes. It goes usually to more unstable things. The more advances it uses, the more unstable things. So I feel like it's useful. It's just that we haven't done enough research on them to know how they could be useful.
Yeah, it's not useful yet.
Yeah.
I'm still having fun doing.
He's shooting lasers
Right?
at space
Yeah.
materials. Like, duh. Since we're on this topic, ask Flame to explain why molecules with noble gas atoms at the center exist, and above that there's multiple states too. Oh, I kind of know the answer to that one. Especially with
Go on.
xenon fluoride. Oh wait, isn't that the same molecule as you have, except instead of iodine there is...
Yeah, basically.
That's hilarious. And I was making fun of this molecule.
Hexafluoride is probably more stable than what I've got.
Yeah, and this is actually what shows the difference in like expertise. That's the sixth sense I mentioned. My sixth sense isn't good enough. To me, xenon hexafluoride seems like the less stable one.
Well, I just know that xenon hexafluoride can like actually exist, and this I have to force it to exist, and it doesn't last very long.
The simple explanation, Harsh, that I know from particle physics is just simply that that noble gas is not bonding is like an really abstract rule due to orbitals. But the bigger the atom gets, the more complex its interactions become. So with bigger and bigger atoms, you not only have to consider just simply their orbitals, but you also have to consider their orbitals, the way distraction in relation to other atoms. At some point, you also have to consider the effect that the nucleus has. For example, palladium is an anomaly simply because its electron structure is different. So basically, the bigger the atom becomes, the less the general rules will apply to it simply because it becomes more complicated. And that's why you will almost never find a molecule with helium, because it's small enough that the rule of noble gases don't bond applies to it really well. But the bigger you get, the less will apply. I don't know if xenon fluoride exactly was the reason, but that's the reason why noble gases can actually bond. Simply because that rule erodes with size. That's my explanation. How would you rate that, Flame?
You basically just said that bigger stuff doesn't follow the rules, right?
Yeah, because...
I'd say that's accurate enough. I think in the case of xenon hexafluoride, it's mainly because, like, since it's bigger, it's not really holding onto its electrons as much. And fluorine really wants to grab some electrons, so fluorine will just stick onto it. And xenon can't pull back on those electrons as much as other stuff because it's so big.
This is wild. That's something I didn't know about. I didn't know fluorine that well. Wait, am I even saying that about fluorine?
Fluorine just wants like I don't know how to describe it. It's the most aggressive atom in the periodic table.
I'll be honest,
I just grab electrons from anywhere. You will never see fluorine without an electron.
That's actually, well, that shows my kind of lack of expertise in this case, but that's cool. I mean, it makes sense, I suppose. It is right after oxygen. So, to me, that makes sense. Top right corner, electronegativity is
the trend with electronegativity is towards the top right.
As much as I hate electronegativity, as much as I hate electronegativity with every fiber of my being, this actually puts it really well. Is there a way to view electronegativity in p-table?
I was trying to figure that out. Let me have a look.
I think there was. I remember. Hold on. Oh, there we go. There we go. So yeah, fluorine is the most electronegative.
Yeah.
And fun fact about electronegativity. Well, two fun facts. First of all, as far as I'm aware, it is just something we made up. There really isn't. We just have to calculate this for every single atom, if I do remember correctly. And actually, not calculate it. We have to measure it for every single atom. So it's not an actual...
It's quite an arbitrary thing.
Yeah, it is extremely arbitrary. That's why I don't like it with every fiber of my being, because this is not really a physical measure. It's more like us saying how much electronegative something is. And second thing, it is exactly what it sounds like. Just... It's so self-explanatory. It's lovely. Electronegativity. It sounds like an idea.
Fluorine just grabs electrons anywhere it can.
Yeah,
and that's how I can make this thing exist with the iodine hexafluoride, because you can't just kind of force fluorine onto it, and fluorine is quite happy to take electrons from anywhere.
Oh, they're both halogens. Oh, that makes it so much worse.
There are these. Google interhalogen and just start going through like Google images.
Interhalogen?
Yeah, interhalogen.
Interhalogen. Oh, I see images. Oh, geez, that's even more. That's with 7, without the minus.
Go on the Wikipedia page if you can as well. Because they might have the
That's
really cursed iodine complex.
That's a
Maybe we need more.
banger of a
Let's see
table.
if I can find it.
Iodine heptafluoride is there, which, I mean, hilarious. Because this is iodine heptafluoride is really your molecule, except
Oh, okay. So search polyhalogen ions. I just start scrolling through the Wikipedia page.
I can guess what it will be. Polyhydrogen ions. Oh my goodness. Oh my goodness. That's a lot of... Okay, well... that's That doesn't look right. That... Oh, why? That's a chain. That's a chain. That's a full-blown chain of fluorine. Okay. No, you see, that looks made up. No, that looks like someone seeing organic chemistry for the first time and saying, okay, but technically, could it work?
Yeah, we just make chains. Yep.
You really can make chain. That is a full-blown chain.
I haven't really looked into this more than just seeing the images and laughing.
That's hilarious. Why don't physicists go with darken as a particle to make sand model compatible with dark energy? I actually don't know. I asked Remco about the thing, but Remco apparently doesn't want to dox his friends or whatever. Cringe. It's a joke for everyone.
Search polyiodide as well.
Polyiodide.
And go on the Wikipedia page.
But that is something I want to know, because a lot of time I've heard the sentiment of wait until they find a new elementary particle, but that's not how the standard model works. Oh, jeez, no. Oh, that... That's a cube. Wait, is that an array of cubes?
Yeah.
Wait, hold on. That's just... Oh, jeez. Okay, so you remember, what was it called? The one in which you trapped a chlorine ion in a cage.
Keep scrolling.
What was... Did... I'm sorry, what? You're just playing Snake with iodine. Hold on. Infinite polyiodine homopolymer? It's infinite. You just have an infinite... Oh, I guess it makes sense if you have a chain. No reason for it to end. That's... Okay, what was the name of that thing in chemistry? Not supramolecular, was it? Wasn't supramolecular chemistry, was...
Mechanochemistry.
Mechanochemistry. This looks like mechanochemistry, where you just...
This is actually more kind of supramolecular chemistry. Yeah.
I mean,
Supramolecular is mostly organic, to be honest.
To be fair...
This is like as close as inorganic can get. Unless you do nanoparticles.
This is such a competitive chemistry level where you just need... You need a molecule inside of iodine in order for it to function. Like, this is what the drunk sadistic professor would put in an exam. This molecule right here. And I don't know why this is the one I find the most... Well, this one and the infinite one too. Or the snake one too.
The snake one is so funny because they've labeled all these different like angles.
Yeah.
Like it's actually a defined molecule where it's got a specific angle.
And also, these angles are so rigid. How can that be a molecule? I don't understand how that can be a molecule. Chemistry is a joke. I mean, there is a lot of things in chemistry which look made up. I feel like you chemists just have so much free time. You draw these molecules. You don't even check. You just draw random molecules and you put them on Wikipedia.
Like, yeah, this might exist. At
oh yeah,
point
totally. Oh
yeah.
I did research that. It's actually highly unstable, but you don't need. That's why it will never work in a lab. But trust me. Finding a new elementary particle will just render the standard model unusable. That's precisely what I mean. That's why I wanna. My next physics video will have that conclusion in mind. The fact that you can't just find a new elementary particle. That's not how it works. We have the standard model, which is the model. So
What do you mean? Just build a bigger collider.
just build. Actually, funny
Find all
enough,
the particles.
that's actually what that video will be called. Just one more hadron collider. That's genuinely what I'm gonna call it, and it's going to be. That's actually where the idea for it came from. I'm not joking. I started writing the script for that video like a week ago, because when I was researching the elementary. No, I don't want to spoil the script, but there you can see just one more particle accelerator, just one more. I swear, I just need one more. That's the title of the video. That is what, and the meme that you've sent, that's going to be in there constantly.
Right.
But basically, yeah. So the reason why you can't just find a new elementary particle is because, well, that's not how the model works. We have theorized the Higgs boson. I think was it 60 years before we actually discovered it, and then it took actual years to discover it. So it's not really wait until they find a new elementary particle, it's more wait until they theorize the whole new model to then prove it. Physics is wild too. We need a bigger hadron collider, that's all we need.
Just build one more.
One more, I swear, one more and we'll
All the
solve all
particles.
physics. Or another one where it was like, physicists are like, oh yeah, just give me one more dimension, I'm gonna solve all physics, just one more dimension. And then Remco replied to that, yeah, but give me one more dimension, I really will solve physics. No conversation on Discord. Finding a new elementary particle. What about polyiodide is actually stable, like it forms its own. I mean, I find this really cool because it really goes to show that in chemistry, it really is at times more like engineering than theoretical science, and most of the time, where you have something that's. It makes sense that the molecules around the molecule would affect it, but to the point where you actually need it. The supramolecular chemistry is wild for that reason to me. Because it makes sense that other things affect the molecule, obviously. The chemist brewing these diagrams up was higher than the physicist cooking up the graviton, I'll admit that. It's a competition. It's a symbiotic relationships. Chemists make the crack, physicists smoke the crack. It is needed for the advancement of science. I mean, dark particles from gravity pretty much, and some propose the weak force as well. If that's the definition for dark particles, then graviton would be a dark particle. It interacts with nothing, well, except gravity. What kind of interaction is that? I'm sorry, I just keep making fun of the graviton because it's an easy target. I mean it. It sucks. The only thing I like more than making fun of philosophers and French people is making fun of French philosophers and the graviton. If there was a French philosopher who would be for the theory of graviton, that would just perfect dopamine levels for me. I had a lecture by one of the researchers who found the Higgs boson. That's so cool, my goodness. Do fields really exist as a physical thing according to standard model, or are they merely a mathematical construct? That's the pickle, Gemma. Yes to both answers. The same thing goes with quarks. That's what I meant with quarks, that quarks blur the line between a concept and a thing. The more in-depth you go into particle physics, or like really small physics, the less things are real in a sense that we would normally classically interpret them as. I know it makes me sound like I'm drunk and just ranting about random things, but that's how this kind of physics works. You go so in depth that asking if fields are real is an odd question. They work. That's all you need to know. They work. They described our reality well. You can't actually check if they exist or not. The only experiments you can do is to check if things behave as if fields exist. You can't actually check if fields exist. There, finally. For clarification, since the topic changed, my previous remarks were regarding the ridiculous atomic structure. He is drunk and he is ranting. Alright. Red book, by the way. We'll have to get it down. That's fun. It's fun. I don't know if I should go through the entire. Oh yeah, the PDF I found. That's incredible. Have you seen it? I don't know if you joined in the stream then, but this one, the 4 pages long one.
I did see. I saw it pop up on stream.
It's so cool to me that they made it. Oh my goodness.
It looks very useful.
It is incredible. It's IUPAC just shrunk, whatever, into 4 pages. Incredible. Absolutely incredible. I still don't understand what trans and cis means in chemistry.
Let me draw on the whiteboard.
This one I'm too afraid to ask.
Because you'll get cancelled on Twitter, or?
Yes, exactly. That's the precise reason. You know, I'm always one to shy away from a controversy. But I do believe that, I mean, I don't like talking about controversial things, like, for example, abortion. Because, I mean, on one hand, I like the idea of killing children. On the other hand, I don't like the idea of women having rights. So, you know, it's tricky.
I've seen that joke before.
Yeah, I know, because I make it every month or so in the Charlie Checkup. You know, new people join in. I need to say it. I don't think I'm cancelable. At this point, no matter what I say, if someone clips me and sends it to someone, they'll be like, yeah, Make It would probably say that. Like yeah.
Okay, I've drawn 2 things.
Right.
These have the same molecular structure, the same formula, right? And if you were to describe the bonds in terms of what's bonded to what, you would describe them the same. But these are 2 different molecules. Right. And these are isomers of each other. And one is trans and one is cis. Can you guess which is which?
Is this one trans?
I'm gonna wait for the stream. Yes.
That was a 50-50. I have no idea why.
Okay, trans means different, and cis means same, usually.
So is it really
like
opposite?
Transgender and cisgender.
Okay, so the opposite side. I mean, I know where it comes from.
Yes.
The only pickle is.
Can you? So the thing is, if I draw something like this and something like this, can you figure out why these 2 are the same molecule?
Yeah, I mean.
But these 2 are different molecules.
Oh, well, hold on. It's because of the missing 2 hydrogens, 1 hydrogen. Hold on. Actually, give me a second. Is it because of how they're going to... Is it because there's only one possible way for these to be oriented? Because of the cyclohexane thing we had before, where basically they want to spread out as much as possible. And so these on... No. Okay, never mind. I have no idea.
Saying, but no.
I have no idea then.
The thing you're saying as well is like this this spread here is the same as this spread, right? The only difference is that this to this distance is shorter than this to this distance. But I get what you're saying. That's not it. That effect is really minimal. You are right that, like, on average, this will probably form a bit more than this, just because these are slightly closer, but realistically, it's not really going to be an effect. Other effects in chemistry are way more prevalent. Okay. The thing is to do with the type of bond. And so, what differences do you know between a single bond and a double bond?
Well, I know one of them is a single, the other one is a... I mean, okay, I'm assuming that's what the difference is.
That is the difference, yeah. But, so it's not to do with the number of hydrogens. I'm ruling that out.
I mean, I'm saying number of hydrogens because this one will have will have less hydrogens, right? Because
yeah.
That's why. But it is, well, a double bond just has twice as many electrons in a bond. Bonded.
It has twice as many electrons in a bond, but can you visualize or draw the shape of a double bond and the shape of a single bond? You might want to draw a pi bond and a sigma bond.
Let's just assume that I can't. Just for the sake, for the funsies, just as an exercise.
Okay, do you know what a sigma bond is?
Yes.
Do you know what a pi bond is?
Yes.
Where does your knowledge end? Okay, so you've drawn these.
Yes, that's the sigma
Okay, but
one,
when
and then
when you're drawing these, do you know what you're drawing in 3D space?
right, yeah. So right here, this is S and S, or alternatively, I think alternatively P this way and P this way. Am I?
They don't need to be s orbitals. It's just that the only bonding s orbitals can do is sigma.
Yeah. So
Whereas
these
pi
are
orbitals
either
can do.
S
Sorry?
and S, as in two balls coming together, or two P orbitals coming head on, or two D, and so on and so forth.
Yeah, any
Whilst
orbital can do sigma bonding, but only the s orbitals can only do sigma bonding.
and pi would be them this way. So the sigma one is them head on, whilst the pi one is them like sideways.
Yeah.
Okay, I know that much.
Okay, you know that. And so when you have your sigma bond, so I'm just going to draw an atom here and an atom here, and they're sharing electron density. And this blue region is a cylinder kind of shape, like you get what I mean, like it's a blob,
Yeah.
right? And that blob is symmetric about this axis. Yeah.
Mm-hmm.
Which means that if you rotate this axis, the blob stays the same. Does that make sense?
Yes.
And so if you have something here, another atom here, can you
They
see
can
that
freely
this,
rotate.
Yeah, this atom can freely rotate
Yeah,
around.
Harsh said. So basically, pi bond is restricting the rotation. As in,
Yes.
pi bond is so basically these two are equivalent. Actually, I don't know if I should. These two are equivalent because this carbon can rotate around, and basically, so it's therefore it's the same molecule. However, the bottom ones aren't equivalent because this carbon cannot rotate around because the pi bond is stopping it from rotating because it has a double bond. And
because actually, and so there's some kind of energy barrier. So you can understand that there is a sigma bond in here when you have a double bond.
oh,
but
okay.
you also have a pi bond, which is like this. And if you were to try and let me just draw. This thing is in the way. Hang on. If you were to try and rotate this around, what you would do is when you get like a quarter of the way here, you're moving.
You need to
these
break
p orbitals around. You're breaking the pi
You need to
bond,
break
right?
the pi bond and reform it.
So in order to rotate it, you have to break the bond.
Oh, so basically, like, in order to get from this to this, it just gets there, but in order to get from this to this, you need some activation energy.
Yeah.
It's a full-blown
it's
reaction.
quite strong energy. It's a pi bond. And you do only have to break the pi bond and not both bonds, but it is still a lot of energy. And
You
so
still need to break the bond.
realistically, that doesn't happen.
Oh, I can actually see it. Oh, that actually makes so much sense, where this one is not a chemical reaction and this one is a chemical reaction. I mean, I don't know if actually by definition it is,
yeah,
but it makes sense as a chemical reaction. Like you have the activation energy you need to fulfill. Actually, you need some energy. In fact, that makes a lot of sense. So, okay, that actually cleared it up for me, because the thing is, I didn't understand why sometimes it was cis and trans, and why other times it was just we don't care about which way it goes. That's what I didn't get.
Yeah. That's fair. And then the funny thing is, when you have triple bonds, so something like this. Notice I'm not drawing corners here because there is no bending on the carbons, right? Because this is sp2, so it's a straight line. When you have the triple bonds, it actually you have two pi orbitals, but they actually end up forming this weird like barrel structure, which is
like a hyper
so they
sigma,
become like a big donut, which basically just means suddenly it can rotate again, even though you've got a triple bond.
That's a banger of an.
But that's very.
Hold on, I need
advanced.
to write down all these things you're saying, for the video, so don't forget, because there are a lot of things
Oh, yeah,
which are really cool. Hold on.
Don't talk about the triple bond thing because it's very advanced. It
Cool
was like
stuff. No, I
me
am
by
going
a
to.
postdoc.
No, actually, I'm going specifically to talk about the triple bond thing simply because it's a perfect way to illustrate the fact that it's an actual physical thing. Like, it makes sense. The thing is, when if you're going simply with the rules and memorizing, then it doesn't make much sense. It feels like an exception. But if instead you're going from the perspective of it being an actual physical thing that is supposed to be intuitive, then it makes sense that they can just merge together into a donut. I mean, not a donut, yes, a barrel, as you mentioned. And then they can rotate. Oh, cool stuff. Hold on.
I need to check this, to be honest, because it was mentioned to me by a postdoc, and I didn't really read about it afterwards. I need to actually fact check myself.
Wait, so a triple bond is 1 sigma 2 pi?
Yeah. I need to check this, because I'm not actually sure it's correct.
Yeah, don't worry, I was gonna double check anyway later on, but actually, you know what? You check it. It's gonna be a walk off my shoulders. Oh, actually, I also have one question after that.
Mm-hmm.
You can wait. It's fine. I think there was one more thing, but that's all I can remember for now. I just want to join this call, it's 3 AM here, that's fine. What if it's all a dream? Such a boring answer. Last live stream was with Tefta, and I mentioned that when Tefta asked me about simulation theory, I don't really have an opinion on simulation theory because I find it as such a boring question. It seems unprovable and undeniable. Why do I have mass in the rest frame? Well, there's Higgs field for you. I'm not going to explain Higgs field right now. I can relate. Triple bonds are even more restricted than double bonds.
So the thing is, like, a lot of sources, like the simple sources, say like, oh, you can't rotate them, but then you find these other sources that are like, oh, it's cylindrically symmetric, so it can't.
Yeah,
rotate.
so
It's like...
yes, we have some sources which are like, yeah, just the pi obtuse can't rotate, but then you have the other sources which go actually independent. Like, oh yeah, when you actually do this one molecule, if you get it just right, then they become a one big cylinder, and we've shown experimentally that they can. Because triple bonds you have two pi bonds, it would be impossible to have cis trans problems because pi bonds overlap because of the phase sign. Pi electron will go to a higher mode, which requires energy.
Like, look at this.
I love it when they just link a paper and then the server doesn't let me go through.
Oh, I can. If you have a paper, I can.
No, that's just we're having trouble finding that site. That's not even them. It's just.
Yeah, this is what I'm describing.
That's so comical looking, by the way. Hold on. 2 pi bond merge forming a long donut-shaped cloud surrounding the sigma bond cloud, resembling a cylindrical hot dog. This, you can tell this was written by a chemist. I mean, that's such a chemist quote.
The thing is, it doesn't really matter whether it can rotate or not, but it's like...
Where did you get this
some
image from?
chemists say that it's cylindrically symmetric, so it can rotate.
N2 rotation. Ah, that's not gonna give me anything. Chemistry. No, it gave me a rotation matrix. Not math chemistry, of course. I'm talking about nitrogen gas.
The thing is,
I guess nitrogen
like,
it is.
it's not gonna matter.
Yeah,
whether
for
the bond is
nitrogen
rotating
gas.
or not, will it?
Yeah, for nitrogen gas is not gonna matter. That's true. But I'm just looking for
But
something to back
for
up the claim.
any triple bond, it's like...
Can triple bonds rotate? It's all to fill at this point.
This is the
Stability,
thing,
rotation,
'cause
hybridization.
Some sources say yes and some say no. So, like, you Google it and then different sources say yes and no. So it's all I remember is it was mentioned to me by a postdoc. I can't remember. We were talking about NMR and electron shielding.
Yes, the rotation of a triple bond takes place. Cool. Can I get a link to like a paper or something? That's
the
all I
thing,
need.
They all just mention. They all just
Yeah.
say it, and they don't have.
All I need is just a link to the
source.
paper. That's it. Because that's a source enough. If you made a molecule and you've shown that it can rotate easily without any need for crazy amount of energy, then that's good. That's proof. Because all this is theory. I want practice. Theoretically, neutral helium hydride exists. I don't care about theory. Practically is meaningless, merely detected because there's no formation of new compound groups attached to carbon to just rotate
I'm
on
trying
their
to remember
axis.
why he brought it up, because I was making molecules with triple bonds.
Oh, so okay, never mind. This is going to be just theory.
Yeah. No.
So, all groups attached to the carbon just to rotate around their axis, bringing no change in the overall symmetry and geometry. So it's... Hold on, if you have a triple bond between... If you have in the carbon a triple bond, can it be bonded to anything else?
It can be bonded to one thing. If there's a triple bond on one side, it has
Yeah,
a
so
single
the
bond on the other side.
carbon rotating really won't matter because
Yeah,
nothing will
that's the
rotate.
point.
It's a
When you
rotating
have the triple
point.
bond, it doesn't matter. So it's a bit irrelevant. I'm trying to remember why it was relevant.
Wait,
like why this,
can it
this
be-
person brought it up to
I
me.
mean, can you... like a molecule with a triple bond that's actually... something bonded to a triple bond on one side and some bond, I'm assuming a single bond on the other. For the rotation to actually matter?
No, because I'm trying to.
I mean, that is what
Explain
it's
this.
needed, isn't it? Something...
It's the fact that the other bond sticks out through the axis of the carbon means that it doesn't matter whether the triple bond rotates or not, because the other bond will always be able to rotate.
Oh, that is true. Okay. So it is purely theoretical.
Yeah. I'm trying to remember why it was relevant, why this guy even mentioned it to me. Maybe I just I'm trying to, because I was making stuff with triple bonds and we were doing the NMR, and were we looking for the triple bond peak? The extra shielding? I can't remember why he mentioned it. The thing is, Dolinchek, you can't have a cis and a trans around a triple bond because the carbon that's doing the triple bonding is sp2 is sp hybridized, so the bond angle on it is going to be 180 degrees. So there's no bending, like there's no angle that something else is going to stick out at to make it cis or trans.
A line can't rotate. Well, if a line rotates, it's still a line around its z-axis.
Because it's 180 degrees, it doesn't matter which way the line is rotated. It's always pointing the same way.
Rather, if a cylinder is rotating, around
If you had
the
additional
center.
alkyl groups, then you'd have a hydrogen with 5 bonds, right?
I mean, I'm still going to mention it simply because there are sources claiming it can rotate, but I will also have to mention that the rotation is meaningless.
Yeah.
Cylinder, but
I would want to find a credible source to like put it in the video. I can have a look more.
I mean, the thing is that the fact that the rotation is meaningless is also cool because that's still a consequence of the fact that, well, it's a physical thing. PDF, please tell me you have some. No, never mind. It's just a PDF. Okay. Actually, this is not terribly important because even if you could rotate, hold on, we can also have triple bonds between carbon atoms. The drawing below illustrates a few important characters of a molecule with triple bonds between two carbon atoms. The first shape. Piss! Damn it! I have a source that's telling me I have a credible source. It is a seemingly credible source that's telling me that they can't rotate now.
Yeah, this is what I was saying. Is like different sources say it can and it can't. See if you can make sense of this.
Are you really gonna give me a Wikipedia page on the atomic orbital?
No, but in the section that I've...
Oh, I see them.
you see the animation?
Yes.
But it's to do with maths, essentially.
That's not terrible. That's not terribly for maths. I could hold on. Let me call my physics guy and maybe even maths guy. No, actually, this is physics guy. This is a bracket.
It's a bracket, so it's physics guy.
It's physics guy. I'm calling my physics guy. I have. Hold on. Why did I ping him? I have a bracket for you to interpret. Trying to sleep, make it shush. No time! I need to know if a donut is a donut or a double or a quad cylinder.
If it's a donut or 2 hot dog buns stacked next to each other.
Exactly, it's important. I need to know. This is, to be fair. Okay. This looks awful, but it doesn't seem all that advanced. A quad cylinder. And then Reblack just said, studies show a donut is in fact a donut. How could you tell I'm a mathematician? What does it have to do with brackets? It's in brackets equation. Wait, actually, I don't know what these brackets mean. Okay, this is 2p1, 2px, 2py. By the way, I just want to say that I could as well, in that segment, say that some sources say they can rotate, some sources they can't, and just give an example of source saying they can, source saying they can't.
I mean...
But instead we're going the most difficult route possible, which is basically analyzing the wave function of an orbital, which...
I mean, that's because the sources I found said it comes from the wave function.
I mean, that it comes from a wave function, but there isn't a single more exact and advanced way for us to do this. I just want you to appreciate the fact that physically, there isn't a single way this could be more exact and precise than analyzing an orbital with a wave function.
Wait, Remco, let me send you
Hi, the Remco. No time for sleeping. I have an important question. We need to know
I
if it's
put it in the maths channel. We're
Yeah.
trying to see if this is correct with the barrel. I'm pretty sure it is, but the thing is, some sources say it is, some say it isn't. I can't find an actual.
And none of them are credible. Absolutely, none of them are credible.
There was also that one. You know that YouTube channel 326? I don't know if you know it. He's a chemistry dude.
No, I
He's
don't
a
think so.
professor. There was one video where he was talking about dinitrogen, and he called it a barrel of electrons. Don't ask why I remember that.
That is oddly specific.
Yeah, it's oddly specific. I have a very weird memory.
Wait, what is
Let's
M
see if I
here?
can find this. It was in a YouTube short, I think.
Hold on, which quantum number is M? That's how bad I am at this. I forgot which quantum number is M. Was it the? It can't be magnetic, can it?
I'm trying to remember as well now. It's the one that does the orientation of the orbital.
Oh, I see. Okay, so for orientations, for orientation 0, we have the wave function imaginary real part of it. All right. So far I'm with ya, which is equal to this. Okay, so far I'm with ya, because you want the... Alright. So far makes sense. Which means for a given principal and azimuthal quantum number, we're getting the wave function of the orbital, which obviously varies based on the orientation, the radical part. With RL and L, the radial part of the orbital, this definition is equivalent to the Wikipedia has
this YouTube short.
Wikipedia has
it's a YouTube short. I know you consider.
Oh, I know this guy. Oh, I know him. Okay.
You know him, okay. I thought I recommended you a video of his before, and
yeah,
like,
I
I don't want to watch a chemistry video because then I'll plagiarize it.
Yeah, that's why I know him actually. I just didn't know the name 326. That's an I don't mean to be that guy, but that's an awful name to remember. 326. This is just 3 numbers. That's not. I genuinely in my head I imagined 3.
I remembered it though. That's the weird thing. Like
in my
I remembered it. I remembered this video specifically because I was like, oh, it's the barrel thing.
Okay, in which case there are multiple preferred symmetry axes, but not single preferred. The real physics are physically relevant when an atom is embedded in a crystalline structure. Real atomic orbitals are also more frequently encountered.
Did you watch the short?
Should I? I don't want the content.
Yeah,
still.
no. Watch it. It's a YouTube short. Like it's about nitrogen stability. Like, come on, what are you gonna plagiarize?
I don't. It's not even about plagiarizing. I'm just content seeing on stream. I'm watching a short on stream.
It's fine. It's a source of information. Okay, he's a professor. This is the most credible source of info we've had so far.
Okay, fine.
The textbooks say nitrogen is so stable because it has a triple bond. Well, guess what? These molecules all have the same electronic structure, and they range from flammable to almost complete.
Okay, I do have to say that it makes sense that the triple bond doesn't correlate to stability directly.
Unstable. Yes, breaking 3 bonds at once takes a lot of energy, but you don't need to break all 3 bonds in one go. And yes, the triple bond is part of the story, but the real reason N2 is so stable is because it's a small, neutral molecule with an unusually high degree of symmetry and 2 atoms that equally share electrons while being electronegative, but not too electronegative. Only nitrogen can do all of this. The full explanation is surprisingly complex, so if you want a full video, let me know in the comments and be sure to subscribe so you don't miss it.
Oh, he didn't even say the barrel thing in this one. He said it in a different one.
Oh no. Okay, but can it rotate?
It's a different shot. But you saw it in the picture, right? The electron density is symmetric.
Yeah. Seems to me like gluing smooth functions together to get funky wave function looks cool. I've never seen this before, don't know how liable it is. I can confirm that my professor would have showed me hot dog wave function if it was a big thing. I just summoned... Okay, you know what? Let's summon Roblox then. One by one. We need someone. One by one, we need Roblox now. Hold on, I can...
I found the other
some
one, but
real
all
objects
it says is it's a barrel, right? It doesn't say. which
Orbitals
one
with
you
quantum numbers. Orbitals with quantum number. I call this orbitals. Can we assign those orbitals such this? Oh, this is just orbitals. I have an idea. I have.
That's Remco. It's not a big thing. Like it's.
It's
This
actually
is a really, really useless.
the thing
piece
is
of chemistry.
the problem here is that we're struggling with two different concepts. Like first of all, we just want to figure out if that's even a thing, and second of all, if it is a thing, we don't know if it would matter in any way.
Well, no, I know it wouldn't. It wouldn't matter for any kind of rotation stuff. It does matter for stability, because more symmetry means
Wait, so
less. Kind
it
of
is
process
so
of
it is
attack.
impossible for the particle to rotate because it has to be, I thought that maybe there would be some
No,
obscure molecule.
It will rotate. It will rotate about that axis anyway.
I just thought
'Cause
there
in
would be
any
some kind of...
context where you have a triple bond, it doesn't matter.
Okay, then never mind. I was wrong. I thought there could be some theoretical molecule with a triple bond and a double bond with a pi, so that it can only rotate on the triple.
You do get metal complexes with triple and quadruple bonds. They have rotational stuff due to where the ligands are. Let me draw. Let me draw. an
Okay, so
example.
where would it matter if a triple bond can rotate or not? So what part of stability? Because you said stability, right?
Yeah.
Make it seeing a make it seeing a hot dog wave function and summons his entire army of scientists. It's important, okay? I really am just getting everyone on board. I also need to bring Alu to really just... I need everyone. We need all hands on deck. I need to know the hot dog is a hot dog. Oh, so wait, what part of stability?
Hey, I found him. Oh, this is a quadruple bond. It's the same thing. It's quadruple bond is just extra. But it was ruthenium, wasn't it? Where was this complex? It had quadruple bonds. Oh, I'm going to my lecture notes. Let's have a look. Come on. I was at 10:30 already. What?
Get access to the full paper. How would you piss off? This is a paper from 1967. Why do I need to pay money for it?
Send me the link. I can get it.
I don't even know if it has the thing that I need. I just...
Just send the link. I can find the.
It's
paper.
simply because it's a triple carbon. I'm hoping it will have some juicy wave function action, which I can understand. And I don't want to go that in depth, but technically, if you have a wave function kind of specified, then in a paper like this, maybe they could have specified that it has like radial symmetry or something. So if they are going into wave functions, that's activated CC triple bond.
Here you go. Here is a very legal file for you to possess.
Oh, I see. There we go. That's... Thank you for this
Which you've
legal
obtained through
file.
legal means.
Which I've obtained... Exactly.
Yeah.
Physicists need to sleep. Fine, Remco, fine. Good night, whatever.
Where is this?
To be
Is it
fair,
this?
I did ask a lot of you, Remco, to be fair. Just gave you a random wave function and tell me if it makes a hot dog.
Oh, it was rhenium, not ruthenium. Here we go. Let me send you these pictures. Here's your first look at a quadruple bond.
You actually sent it to me. Yeah, I remember it was months ago.
Oh, I've sent it to you. Yeah.
I remember
probably.
that. Yeah. Quadruple bond. That's
The
fun.
thing is, in this, the things are aligned. The ligands are aligned on either side, which suggests the orbitals aren't symmetric about the axis. Because if they were, then the ligands wouldn't be aligned. Because the ligands would want to be at 45 degrees to each other, right? So that they're slightly more spaced out. When I say ligands, I mean the chlorine atoms.
Wait, what's the name of that legit paper finding thing where you just add a link and it gives you legal papers?
Sci-Hub.
All right. Well, I wish you didn't say it on stream because now I'm
Wait,
my
you asked
claim
me.
might be
You
questioned.
asked me.
I hope you would link it to me. All right. It's
You said, "What's the name of it?"
that's fair. I can see.
You
All right,
asked for the
let's
name.
just agree to disagree. Let's just say that the fault is on both sides.
No, you asked me
Let's
the name.
just say that we both reacted maybe not the way we should have.
I reacted exactly how I should have because you asked me the name, and I said. The name.
Obviously, when I ask for the name, you're not supposed to give me the name.
I'm supposed to just
Everyone
give you a
knows
link.
that.
Yeah.
My goodness. Check my hold on.
Are you trying to figure out how to get the DOI?
What's the OI?
Oh, you don't know.
I'm not the iron scientist. I don't know.
DOI is like an identifier for every.
Oh, okay, then I know it is. Never mind. My brain doesn't think of words this way. Graphically, whenever I see DOI, I know that it is because I just copy it every single time.
Yeah.
But I never acknowledged in my entire life that these are actual letters DOI. I always saw it as. I knew they were letters, but my brain always saw it as a character. Just meaning,
Right.
link to the paper. That's how I always saw it. Basically what it is. I'm thinking about what I'm looking for. Two bonds. I need...
I might need to go in a bit.
It's fine. You're gonna leave... Oh, you just came in.
It's 10:30. I have.
You came in, chucked me into a rabbit
Bro,
hole.
I spent how long? 10 to 6. I spent 8 hours in the library today
That's
after
fine.
my lecture.
I'm glad you
Then
can relax
I
and
went for a walk
unwind.
with a friend, and then I came back, and then I just joined the stream, and I haven't done anything else.
I'm glad you can relax and unwind by doing more research on stream,
Yeah.
except about some extreme
Exactly, that's
obscure
what I mean.
things.
I spend my whole day straining my brain doing whatever, figuring out lasers, and then I come home and I rest by talking about chemistry and playing puzzle games.
Resonance theory. I don't know.
I think I'm gonna go.
It's fine.
Since you're looking at these anyway, I might find something
Fine.
tomorrow.
No, it's right. I'll have something by
I need
tomorrow.
to rest though. I've got a lecture. Do I have a lecture in the morning?
Well, that sounds important.
I do have a lecture. What's it on?
No way, a link didn't actually give me the thing and I need to pirate. I mean, legally obtain it through legal means. That's 6 pages. I don't like it. That's a bit short. Boy, if I had the nickel for every single time I had that.
6 pages is fine for a paper.
That's suspiciously short. I'm not used to
They're
them
meant
being
to.
this short.
They're kind of forced to make them short because if it's too long, then it doesn't get published, right?
No, I suppose that's fair. Wait, isn't this the same?
Oh, it's
Wait,
a
what am I
protein
doing?
NMR. That's my lecture.
No, wait, hold on. That's the wrong. I opened up the wrong one. I meant. Oh, whatever. Fine. Come to warnings. Advanced diffuser polarization employed. First, the easy route, and then. It wasn't calculating molecular properties are very dependent on the basis and initial level calculation. In the last years, systematic studies using multivariable statistical techniques of factor design. Perform known to get deeper inside how the calculated properties. As a successful plan. Rotational constant, vibrational frequency, infrared property. By the way, I don't want to keep you here. I meant it as a bit with me being upset
okay.
that you're
No,
leaving. No, it's
I'll go for now.
it's fine. I meant it as a bit. I want to make
I'll
that
be around
really
tomorrow.
clear.
Yeah, it's fine. I'll be around tomorrow, like same time. I don't know. Your stream times vary, don't they?
Yeah, wildly.
Wildly, yeah. I'll be around tomorrow.
I'll try to find
Be in the
something.
library until like 4 and then get fed up. We'll see.
I don't want to drain you any further. I understand you're busy doing
Oh, no, it's
smart
fine, it's
people
fine.
stuff.
It's just because I need to talk to my mum and it's already almost 11.
I get it.
All right.
That's a reference to the Tom Cardy song, which I respect. All right then. See ya. Bye.
Have a good one. Thank
Bye.
you for having me, and good luck researching. I'll see if I can find more later. You can message me stuff.
Well, I'm gonna look through a couple and then I'm gonna give up. So yeah.
Okay. All right. Have fun.
See ya. Bye. There's also need sleep. I can lecture in the morning. The more wave function. All right, Beardman. Oh, Biden. Everyone's leaving. Oh no. I'm gonna leave too. Why am I trying to get into that? Actually, it won't matter. I don't need a concrete source. Simply because I can't just say that, sources vary. I can't just show a source supporting the claim and source disproving the claim. Why am I trying to find a credible source? It doesn't matter. Alright, yeah, you know what, I'm gonna end the stream. I just realized I'm silently reading on stream, which will... As entertaining as it would be to watch, I feel like we're gonna have to cut this one short. I'm falling into a rabbit hole. Said Macon, then kept on reading. Why did I join at the end? I'm sorry, Greg. I'm sorry. I don't have. I know I would need to find what all the effects are there. Rotating. No, you know what? Screw it. I'm giving up. Sometimes you need to quit when you're behind. For now, that'll be it. It's been a long stream already. I'm gonna go script the video because, as I mentioned, by today I want to at least couple first chapters finished, and this was still a really fun stream. Flame taught me a lot. I mentioned a lot of fun facts. I'm gonna use in the video. Obviously, I need to find sources for this. Fortunately, they are all simple enough so that library text should suffice. And for now, I suppose that'll be it. Thank you, Van, so much for watching, and have a great day. Bye.